In this video, we will evaluate a few more indefinite integrals. So starting with the first example, let's make an observation that we've made in the past. When differentiating, oftentimes it may be useful to first simplify algebraically. And the same thing is true here. We don't have any rule for indefinite integrals that allows us to somehow break this up over multiplication, but we can break up indefinite integrals over addition. So what we want to do is take the square root x and distribute it through both of those terms in the integrand. So remember, square root x is really x to the 1/2. So this is 6x to the 1/2 plus 5x to the 3/2. And in both of these integrals, we note that they're of this form, the indefinite integral of x to the n, where n is not minus 1, and the indefinite integral will be 1 over n plus 1 x to the n plus 1 plus c. So breaking this up into two, we will have 6 indefinite integrals of x to the 1/2 plus 5 indefinite integrals of x to the 3/2. In the first, our value of n is 1/2, and 1/2 plus 1 is 3/2. So this is going to be 6 times 1 over 3/2 x to the 3/2 plus 5, and let's see here, now n is 3/2. 3/2 plus 1 is 5/2. So 1 over n plus 1, which will be 5/2, x to the n plus 1. So 5/2 plus c. And of course, we should always do kind of the easy simplifications here. So dividing by 3/2 is multiplying by 2/3, and 2/3 of 6 is 4. So 4x to the 3/2 plus we have 5 multiplied by 2/5. So 2/5 of 5 is just 2 plus c. So a key observation was that once we get everything in terms of sums of powers of x's, we're in the ideal situation to undo the power rule. So in this next example, let's go ahead and break it up over addition and pull out the constants. So 2 times the indefinite integral of square root x, which we've seen is more conveniently expressed as x to the 1/2, plus 6 times the indefinite integral of cosine. So in the first one, it's a undo the power rule with n equals 1/2. So 1/2 plus 1 is 3/2. So we have 2 multiplied by 1 over 3/2 x to the 3/2. And then the indefinite integral of cosine is sine. That was one of the properties introduced in the previous video. So 2 divided by 3/2 is 4/3. X to the 3/2 plus 6 sine plus our constant. So one more typical example here of an indefinite integral. Now once again, the observation is without algebraically manipulating, I have no known approach that I can use. That is to say, I can't say it's the indefinite integral of the first function times the indefinite integral of the second function. That is not true. So instead, what we need to do is algebraically manipulate. And here, the simplest algebraic manipulation is to just take that integrand and first expand out the 2 minus x quantity squared. So that will be 4 minus 4x plus x squared, and then go ahead and take the x, which is out front, and distribute it into each term. So the indefinite integral of 4x minus 4x squared plus x cubed. So anti-differentiating now, and I'm going to do it a bit more quickly than the previous examples, just doing this term by term. So in that first piece, it's x to the first, so our n is 1. So what we are going to get is the 4 times 1/2 x squared. Then minus 4 times the antiderivative of x squared. The n is 2, so 1/3 x cubed, plus the antiderivative of x cubed. N is 3, so 1/4 x to the 4th. So just simplifying 4/2, so 2x squared, minus 4/3 x cubed, plus 1/4 x to the 4th, plus c. And hopefully after going through and evaluating a few more examples, this process will become as quick and as efficient as it would be to differentiate polynomials.